Hello viewers, welcome to this video lecture series Reprogramming. Today's topic of discussion is to find out how the values for float data types are stored in memory. The following is the procedure to know how a float value gets stored in the memory. So before I start explaining this topic with an example, try to recall the points about the float data type. So float is a data type which is used to store the floating point numbers. What is the syntax for the float data type? You use the keyword float followed by the variable. Suppose if you are writing the variable name as price, okay, you are assigning this variable with some value 9.75. So in this case, what is that you have done? This is actually the data type, that is the keyword, and this price whatever you have written is the variable name, and 9.75 whatever you have given is what? The value. This is the syntax to declare a variable of float data type. In case of float data type, the precision digits are 6. That means suppose if you are writing any number, let me take for example 12.36428, how many digits? 6 digits. Okay, number of digits after the decimal point can be how much? Up to a maximum of 6. So this is what we call it as precision. So the number of digits, that is the number of precision digits in case of float data type is 6. And memory size, how much memory does a float data type takes? It is definitely depends on the compiler. So float data type has a memory size of 4 bytes. If it is 4 bytes, 1 byte is how much? 8 bits. If 1 byte is 8 bits, then 4 bytes is how much? 32 bits. So 32 bits are used here to store a value of float data type. See, this 32 bits once again are getting divided into 3 parts. The first part, only 1 bit is used for storing the sign, okay, the sign of that number. If it is a positive number, it is 0. If it is a negative number, it is 1. I'll explain in detail regarding this. Just time being, you remember 1 bit is what? To store the sign, and 8 bits are used to store the exponent part. 23 bits are used to store the significant bits of the number. So let me tell you what do you mean by significant bits, what do you mean by exponent bit, and what is a sign bit. So these things I'll be telling you in detail with an example. Now in order to find out how a float value gets stored in the memory, there are few steps, or we can say there are 4 steps basically. Step 1 is what? To convert the floating number into binary. The very first step is you have to convert the given floating number into binary. Now what is the floating number example? Let us take an example as 9.75. Now this 9.75 has to get converted into binary. For this, what is the procedure? First, see, in this number you can divide this as this number itself into 2 parts. This is the integral part of the number, okay, and this is the fractional part of the number. Now you can start first converting the integral part into binary. Here it is very simple. Number 9 getting converted into binary, it is very easy. What is the equivalent binary number? It is 1001. Yeah, this is the binary. Okay, conversion. I have converted now 9 into binary, which is 1001. Now we are having what? The remaining is 0.75. Now 0.75, how to convert it into binary? The procedure is you have to divide this 0.75 into 2. Okay, once you multiply this 0.75 by 2, you will get how much? 1.50. Now in this 1.50, what you have to do is you just keep this 1 bit aside. Okay, that means the remaining is how much? The remaining part of this number is how much? When you keep this 1 bit, it is 0.50. Now 0.50 you multiply again by 2. How much you will get? 1.00. Once again this 1 bit you keep it aside. That means you are collecting all the 1 bits. That means you are trying to multiply the number by 2, and you will repeat this procedure until you get 00 after the decimal point. In this example, we got 00 in just 2 steps. In the first step we got 0.50, okay, then we have to multiply again by 2, then we got 1.00. Now we'll stop this process. And what are the digits? From the first step we got 1, from the second step we got 1. Suppose if you do not get this 00 in the second step, then you will be doing it once again in the third step, fourth step, and you will be collecting all the ones, and then you will include this ones in the integral part. The binary value for 0.75 is what? 1 1. Okay, 1 1. That means this one and this one. Okay, so now you got to know the procedure how to find the binary value of a decimal number. If I have to write the binary value for 9.75, then what I'll be doing, I'll take this. What is the value for 9? 1001. Okay, dot 75. 7.75 is how much? 1 1. So this is for your 0.75 and this is for your 9. Result after the first step is this much. Okay, now let us see what is the second step. In the step 2, whatever is the binary number you got here, you have to write this converted binary number into normalized form. I'll first write the sentence, then I'll explain the procedure. The step 2 is what? Write the converted binary number to normalized form. Now we'll carry out the step 2. So normally for floating point numbers, remember normalization is like this. Always you have to get 1 dot significant bits multiplied by 2 to the power of exponent value. But we got the binary value as this much. You have to write this binary number into the normalized form, and the normalized form should be what? In this of this kind, wherein you are writing 1 dot. So now suppose if I have to place the decimal point after 1, that means binary 1 dot, then what I can do is decimal point, if I have to shift it by 1 position, then value will be how much? 100 dot 111, but I have to write it what? Into 10 to the power of 1. Fine, because I have shifted this decimal point to the left side by 1 position. Suppose if I have to shift it by 2 position, then I can write it as 10.0111 into 10 to the power of 2. Because I have shifted the dot by 2 positions, my exponent value is what? How much now? 2. If I have to shift it by 3 positions, then I will be writing 1.00111 into 10 to the power of 3. Now I will stop here, because what is that? In the normalized form, I have to see that the decimal point is appearing after 1. Okay, so after this 1 bit, the decimal point has come now. I will stop the process here, and then I will find out what are the different values which I got from this number. That means I have got the numbers like this. The exponent value what I have got from this number is how much? Exponent value is 3. You can check here. So I have written here 3. Then what are the significant bits which you have got? The significant bits are 00111 are the significant bits. Fine. Now this is what the step 2 procedure. Next comes the step 3. In step 3, what you have to do is you have to add bias to the exponent. Process is very simple. First thing is you remember the formula to calculate bias value. This is the formula to calculate 2 to the power of n minus 1 minus of 1. So what is n here? N is the exponent bits. If you remember in the very first part of the session, I have explained, I have given here this one. Okay, the exponent bits are what? 8 bits. So the n value is how much? 8. So the n value is 8. If you substitute here 8, then how much you will get? 2 to the power of 7, yes, minus 1. 2 to the power of 7 is 128, minus 1 is how much? 127. Now what you have to do is this 127 from here, whatever you got from this formula, plus you have to add the actual exponent. Actual exponent is what? This one. What value you got here? In step 2, the exponent value is 3. So 127 plus 3 becomes what? 130. Now this 130, you write it into binary. What is the binary number for 130? Binary value for 130 is, the final step is now step 4. Okay, and step 4 is what? Actually how you are going to represent it in the memory. So the representation in the memory, you have to show it in the step 4. Representation in the memory, this step I have to show you in detail. So I have shown here completely all the 32 partitions. Now I'll fill the values here, because I have to fill values in how many parts? We have the signed part, you have the exponent part and you have the significant bit parts. So these are the three different parts here to store a float value. And sign only 1 bit, exponent 8 bits, significant bits are how many? 23. So let us store these values. First bit is what? 0, because this 0 is your sign bit. It will be 1 in case of where? In case of negative decimal numbers. Suppose if this number was minus 9.75, then since it is a negative number, the sign bit will be 1. But now we have taken a positive decimal number. So here sign bit is what? Sign bit is 0. Next you have the exponent bits. Exponent bits already how much you have got? See, this is your exponent part. How did you get? These 3 bits were the exponent bits, that is 2 to the power of 3 we got no in the step 2. That 3 plus the bias value, these actual exponent plus the exponent bits that are obtained from the bias step, 127 plus 3 becomes 130, and in the binary it is 1. So that we have to write down. Let me use a different color here. And what is that you have to write down now? The significant bits. How to write the significant bits? Look here, from this also you should eliminate this binary number 1 which is before the decimal point. Actually you got from step 2 1.00111. okay, from step 2 the significant bits what you got is 1.00111. Now while writing in the memory you have to start only the bits that are there after the decimal point from 00 onwards. Bit values will be 0, 0, 1, 1, 1. Fine. Now how many bits are there? Actually 23 bits. But what is that you got from this number? 1, 2, 3, 4, 5, 5 bits. So the remaining bits you have to fill with zeros. So all the remaining bits you have to fill with zeros. So these are your significant bits. So this is how a number, that is the float value, gets stored in the memory. And this is what? This is a positive float value because you have taken 9.75. In case suppose if the number is minus 9.75, the exponent part and the significant bits will remain same as it is whatever I have shown. Only the sign bit will change here. So in this case, if it is a negative float value, then the sign bit will be 1. This is how a float value gets stored in the memory. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.